Okay. All right. Well, welcome everybody to the December 12th, 2024 edition of the Technical Advisory Council of the Confidential Computing Consortium. We are an open and collaborative community. If you haven't been here before, we're going to invite you to introduce yourself in a couple of slides. We all get together periodically to help make the world a little safer place by promoting the adoption of confidential computing. We also abide by the Linux Foundation's antitrust policy, and you can read that at linuxfoundation.org/antitrust-policy. This is our last meeting of the calendar year. We'll continue to do some work, I'm sure, right up until the end of the year. But as far as TAC meetings are concerned, this is the meeting where we're going to try to make sure that we have a bow tied on our 2025 planning. That way we can hit the ground running next year. And then we have two tech talks today. We've got James, who already briefly introduced himself, but we'll have him introduce himself again, speaking on the Lisbon account protocol. And then we should have a talk from the UCLA Trustworthy AI Lab, who joined as associate members recently. And then what do we have here? I think that's just a redundant 2025 planning at the back end of the agenda, and then maybe a couple announcements as we get into things. Any other major agenda items for today? Oh, you know what? There was one other thing. There was the documents from the GRC SIG. I'll see if I can pull those up between agenda items, and we can just kind of check in on those as we go. Okay. So everybody's welcome to contribute to our discussions and everything that we build in software and in documents. We do have voting members, and so we just check in to make sure that people are here. But we don't typically tend to need to vote on anything except new project creation or when we do budgets. Do we have Nathaniel today? Don't see Nathaniel. Paul, thanks for joining, Paul.
Yes, present.
And Catherine? No Catherine today. How's about Howard? No Howard. I'm here. What about Henry or Kevin? Well, that's a shame. Alec?
I'm here.
Trustworthy Alec. Thanks for joining. Fritz?
I'm also here.
Wonderful.
Do we have an untrustworthy Alec? I wasn't aware of one, but I like
He joins every other week.
Okay.
Which one do we have now? It's actually interesting. Can we trust
Apparently
you to
this
say
is
that
trustworthy.
It'll become.
But can we be sure?
Yes, I think probably reliable was the word I was searching for. Alec has great attendance, as does Fritz and Yash. Thanks for joining also, Yash. What about Mingshen or Yao? Okay. All right. So now let's move into the the part of the meeting where if you haven't had a chance to introduce yourself to everybody else here, feel free to just jump off of mute. If two people talk at the same time, it sorts itself out pretty easily. So don't worry about coming off of mute. We like to know where you're joining from, how you like to be addressed, and importantly, what your interest is in confidential computing. Okay, well, maybe we have people who have already all been introduced today. So I'm going to just flow along, but if you later want to introduce yourself, just feel free to do so when you come off to speak. So last time we did most of our 2025 planning. We'll wrap that up today. We talked about the QCon activities and the mentorships that were now listed on the governance repo. Mark introduced 3 papers that the GRC is looking for review on. And we had a tech talk about ILET from Piot. And that was what we covered last time. So we've got 3 announcements out here today. There's the mentorships that I just mentioned briefly, and maybe somebody can drop the link for those in the chat. Please circulate those amongst your professional networks. The goal of these is to bring new people into the community that might not otherwise have some job-related task that would bring them more directly to our line of work. We already have a few tech talks lined up for next year. This has been a really strong pipeline that's been developed over 2024, thanks in large part to Fritz. So it's looking like it's already going to be a busy schedule. So if you have something that you want to get on the agenda, the sooner the better for your chances of getting on early in the year. And then annual project updates. So typically each project comes in once a year and we do an update. I'm not sure if there's something else to be announced on this. No? Okay. All right, and then Mike, you asked for a couple of minutes. That probably fits into this announcement section.
Okay, thank you. Just to say that I was in Amsterdam yesterday and the day before to attend a mini workshop run by the LF around the new European Union Cybersecurity Resilience Act, which is going to impact everybody, is what it comes down to. I am keeping an eye on it and getting involved from the CCC side. And I'm very happy, firstly, to encourage other people to get involved, and I can help you do that. But also, I will be sort of collecting information and also, collecting questions from people. It's an 81-page piece of legalese, which takes some reading. I've read it a couple of times now, and just to say, I will be feeding back on it, but. There's a lot to be done, and if anyone wants to get involved, please let me know. It's generally there's a number of tracks, some awareness, some standards, and some sort of supply chain tech stuff. But it's something that I was asked to look into by the governing board, and I will continue to be doing so. So that's my 2 minutes. Address questions to me. I'm very happy to field what I can.
All right, that's great, Mike. I think going forward, a lot of the work that happens with compliance and things due to regulations are pretty germane to what we deliver with security technologies. Is my audio still choppy?
No, it's good.
Okay.
I have a question to.
Yeah.
I have a question. Did there was any discussion about this new Google quantum chip and its impact on confidential computing and security in general?
No, I don't think there was. I think everything still tends to be fairly theoretical at this stage.
They claim it is not theoretical. It is a chip is there.
Yeah. So the chips are there, and they continue to increase the number of qubits. It's something that Mike and I were kind of joking about at the beginning with his new computer. But the ability to produce an attack that would defeat anything that delivers at acceptable cryptographic strength today, those kinds of attacks are not yet realized in in public, as far as I'm aware. We did have some talks over the summer, if I'm remembering my calendar right. We had two different talks on post-quantum cryptography, and so they both kind of projected out that the time frame for that impact is still in the distant horizon. But what a lot of projects do now is they increase their they increase the number of bits in the algorithms that they use, so that they have some additional resiliency to quantum algorithms.
Okay. Thank you.
Yeah.
But again, they claiming they have quantum supremacy is questionable by some researchers.
Okay. Yeah. So I think what I would like to do is we'll hit these objectives after we hear from our first tech talk. And because James was here so promptly, I would like to invite him to come forward and do his talk first, if that works for you, James.
Yeah, that works for me. Thank you.
Sorry, I just joined. I
Oh,
apologize.
hey.
Sorry, can you hear me?
Yeah, we can hear you.
Sorry, let me turn on my camera. I apologize. I'm in LA, so I by default I think it's no, yeah, but yeah, sorry about it. Yeah.
Yeah, no worries at all. There's always some wrinkle in trying to join a meeting. So, as I've just teed up James, why don't we let James go first, and then we're gonna come back to our 2025 objectives, which should be a pretty short discussion, and then we'll get into your tech talk. Does that still work for you?
Yeah, no problem. Yeah.
Okay,
Thank you.
great.
Awesome. Dan, can I get permissions for screen share?
Yeah, I gotta stop sharing in order for you to do that.
Let's see. Lovely. Cool. Fantastic. So thank you everyone for having us. Myself, James Bork, CEO and co-founder of Into.xyz. My CTO, Stephen Mathieson, is also on the call. Originally from Silicon Valley, from the Bay Area, but now living in Paris. So kind of changing the environment a little bit, getting a better sense of kind of the global landscape. We're blockchain guys. We're I don't know how many blockchain folks you guys have joined. Kind of got started in 2016, really as a hobbyist, and then we went full time in 2019, mostly on all the infrastructure that was missing for a lot of these decentralized architectures, access management, data encryption, that kind of thing, and it led us to really focus on multi-party computation. So our first kind of main goal was a lot of research into key storage in a decentralized way, in a way that was kind of acceptable for our community. But that quickly led us into private key generation and private key management. In 2019, a lot of our research was focused on using trusted execution environments in order to more safely perform these computations, but ended up going with multi-party computation in 2021. So our MPC protocol is called the Lisbon Account Protocol. Our company is called Into. At that point, we were traveling a lot backward from Lisbon, so it just kind of made sense. But now that we've kind of concluded our multi-party computation chapter and starting to look at actual customers and actual implementation, we're seeing more and more demand for confidential compute. And so really wanted to take this opportunity today to kind of establish a baseline, at least for us, what MPC is, and then explore from a threat modeling perspective the opportunities to improve multi-party computation using confidential compute. I'm going to do my best to keep this between 20 and 30 minutes, so we won't go too far into the cryptography, but hopefully enough to establish a baseline and hopefully have some decent Q&A towards the end. So at a very high level, multi-party computation, it's the goal is still some kind of an output, but instead of performing this computation on one machine, it's typically performed on multiple devices. These devices are also, at least in our environment, typically controlled by different parties. And then once that computation has been done, the final output is aggregated and then shared amongst the group. The real goal here is to minimize any opportunity for a single point of failure. In our context, our protocols, we strive to be leaderless and trustless, and typically lower that the bar, the technical requirements for performing this computation. Some of these limitations, MPC for us really focuses just on key generation and key signature. And this is almost entirely limited to elliptical curve cryptography. So we do a lot of EC DSA and Edwards DSA, a little bit of BLS. We rely very heavily on local compute, but as I mentioned before, no single machine ever does all of the computation. And then probably the largest limitation is that, this is really not for general computation, and specifically not for encryption. There has been some good progress in the past couple of years for threshold encryption, particularly kind of within the context of fully homomorphic. But we're kind of right now limited to just key generation and signatures. So as I'd mentioned before, right, our journey kind of started with trusted execution environments. And so we wanted to just kind of start with hardware security and confidential compute and MPC. Are we really looking at substitutes, or are we looking at complements? And so kind of originally, because of the values of decentralized architecture of the blockchain community, we ended up leaning with MPC and really running with that. But the reality is that confidential compute and HSMs do provide a lot of advantages that you simply can't achieve with multi-party computation. It's definitely more mature, right? Practical multi-party computation is only, I'd say, probably 5 or 6 years old. It's also much more sophisticated. You can deploy confidential compute in a much greater variety of applications, from trusted execution environments, Intel SGX and AMD chips, to like the TPMs that are going in everything. And then you got like your enterprise grade HSM. But for MPC, kind of what really led us to it was that we were able to deploy this in a decentralized, permissionless, and mostly unsecure environment, to still have reliably secure key generation. It's also typically slower. So then at the end of the day, even though we went with MPC, we're kind of coming full circle and really starting to look again at using confidential compute to kind of fill out some of our blind spots. Yes, Mike?
Just a quick note. If you go back a slide.
Yes.
Just so you know, our definition of confidential computing doesn't include TPMs or HSMs. It's specifically TE based. That's just FYI, really. That's what the consortium's about. Not that not that the other things aren't useful in different ways, but it's not what we count.
Okay, so just to clarify, what is your definition then of confidential compute?
Is the performing protection of data in use using cryptographically attested hardware-based TEs.
Okay, fantastic.
Good job, Mike.
Appreciate it.
I should remember it by now. I wrote most of it, and B, it's been around for about 4.5 years now. So,
well, for us, definitely most of the opportunities in the hardware security and the protected compute. So that's hopefully we'll stay on topic.
cool.
Just to get this out there for us, like I want to just be completely frank, like what the blockchain is supposed to be and what a lot of blockchains are today. There's a discrepancy there. So for us, it's a peer-to-peer network with a consensus mechanism, and we have incentivizations towards decentralization and greater distribution, again, minimizing single points of failure. For us in particular, the focus was really more on the global computer elements of blockchain computing and not like Bitcoin as digital cash and cryptocurrencies. And so we were really limited by the virtual machines that were around in 2017, right? Limited access to compute, limited access to storage, non-existent access management and data storage. right, but ideologically driven towards this idea that we should be pushing towards decentralization, reducing concentration, and then you have like all your crypto punk, crypto anarchy, right, autonomy, privacy, self-sovereignty, etc. But again, we're not here to talk about blockchain. So at a high level, MPC, for those that aren't familiar with it, this is kind of how it works. I apologize that the graph is a little bit hard to read, but we start off with verified secret sharing. And in our case in particular, it includes a pre-registration phase. We start with the assumption that you have an address or an identifier for the other participants. The proposer goes ahead and creates a secret and then starts this process of sharing those secrets in a verifiable way in order to create a pool of qualified participants. This pool of qualified participants will then share proofs to each other. Typically, this is using some form of a zero knowledge proof, in which if everything checks out, then you know who's supposed to be participating in this protocol and who is not. If someone is there that is not supposed to be there, then we'll go into a dispute resolution phase, in which case you'll actually expose part of that private key. The rest of the community will jump in. And at the end of the day, we'll get to this point where we now have a qualified pool of participants. This qualification is both to share secrets, but also to establish secured channels of communication. In our protocol specifically, we use the blockchain as our bulletin board, effectively, right, as a means of posting and retrieving information from other participants. But if this is like a multi-party computation-based like network service, right, you might be doing other forms of communication. And then ultimately, the output is a shared public address, right? And so everyone will contribute some key material, some public-facing key material to the group. And then once everyone has participated, then anyone can go ahead and aggregate that information. And then you now have a shared public address with multiple participants involved. So it's a very elaborate way of performing a key generation, but again, in a way that strives to reduce single points of failure. But as mentioned earlier, MPC is not a silver bullet. So as we kind of went through our development, once we had a working proof of concept, we did bring on an external auditor for some collaborative threat modeling. So we did a simplified version, a hybrid of STRIDE and DREAD methodologies that really ended up bringing up kind of three main areas of opportunity to plan for and reduce our attack service for our protocol. And so those are kind of generalized blockchain threats. Specifically, threats within the decentralized key generation process was our most substantial. And then actually using the account, right, in the formation of threshold signatures and how the protocol dictates that. So with the blockchain, there was a lot of kind of general blockchain problems, including forking, 51% attacks, and Sybil attacks. Some of them were specific to the way that blockchains work, like ordering and memory pools. And a lot of these were also just internet problems, right? DNS hacking, problems with TLS or HTTPS, clickjacking. This is, base threat model stuff. But one of the most substantial risks was actually just in the management of credentials at scale. Just as an example, recently, Solana, one of the major ecosystems, they had a core library, a Web3.js library that was compromised due to GitHub credentials. And so for 3 updates, they actually were pushing code that was malicious, and people were losing their private keys when they interacted with anything that used this library. And so again, probably a little bit outside of Mike's definition of confidential compute, but an opportunity for better management of credentials definitely exists. Where the rubber really hits the road for us is in this distributed key generation. Because it is so heavily dependent on local computation, any degree of compromise on that local machine obviously introduces a lot of risk to the protocol. And whether that amounts to just bad computation, poor encryption for secret storage, or even bad randomness, right? A lot of the advantage of using a trusted execution environment is that you have reliable randomness. So as an example, if your proposer injects bad randomness into and results in bad encryption for their secret, every moment then after in the protocol is effectively compromised. When the proposer first begins to create an account and starts this protocol. There's no degree of forward secrecy, right? You can't really introduce ephemeral keys yet. So there's a lot of limits and a lot of risk at that moment. So obviously, just for practicality, we weren't able to mandate the use of trusted execution environments for the distributed key generation. But in the future, and especially within environments that have higher requirements, we definitely see a huge opportunity and starting to get a lot more asks for this. So as an example, like this would be a fairly standard implementation of our protocol, right? You have end users that are participating in the protocol. You also have applications and hosted services that are participating in the protocol. And at any single one of these points, we could leverage at scale trusted execution environments to improve this, right? Whether it's, again, TPMs, if it's the biometrics on your cell phone that you're using to go ahead and log in, to your desktop computer that's participating in this elliptical curve cryptography, or the hosted service itself, which we need for scale to go ahead and use some form of bare metal security, especially in an environment where there's hypervisor risk. We also, right, there's a recovery factor that we've introduced that can use things like hardware wallets, but also use trusted execution environments to go ahead and back that up. And so all of this is, again, very specifically for the computation. There's this kind of much greater factor that encryption doesn't really happen with MPC. And so if we're able to use trusted execution environments as well for the encryption and the communication process, there's a ton more of opportunity kind of in this MPC kind of integration. The last one is threshold signatures. So because there isn't a single party that has a aggregated private key to go ahead and sign with in multi-party computation, we're forced to use threshold signatures. So typically this could be something like 2 out of 3. But it also has a substantial risk because this is the actual use of the account, and specifically in a blockchain environment, this enables you to transfer digital assets and also transfer ownership of this account entirely. And so one of the biggest risks within the threshold signature component of our protocol is the manipulation of the protocol itself and running it, executing this protocol in an unsecured environment where someone can manipulate either the perception of time, the ordering of the process, or of the deadlines. And so if any of this is changed, you could inadvertently submit a transaction or perform an action that wasn't actually what you signed, right? It's we're using a form of blind signing. And so hoping that using trusted execution environments, we can further make this process safer. So at the end of the day, the big question is, does confidential compute increase or reduce the attack surface of multi-party computation for decentralized environments? And as you can see here, I think ultimately there's more advantages to using confidential compute than disadvantages, right? We can substantially lower the risk of compromised local devices or hosted services that are participating in the protocol at scale, which is really why we're starting to look at confidential compute. Much stronger protections against hypervisor attacks and compromised hypervisors. So pushing that bare metal security element to it. Better verifiable randomness, better execution, secure execution of critical cryptographic libraries, and better encryption at scale. Some of the pushback that we got early on when we were trying to deploy trusted execution environments for blockchain was this kind of, we call it, I don't know, they refer to it as proof of intel, right? But it's the centralized attestation that's required to spin up and provision your trusted execution environment. Good example of that would be like the MSI compromise from, I think, 2 years ago, where the root master key for a lot of the execution environments was compromised. Then MSI and Lenovo hardware had to be reprovisioned. We also found it difficult in a non-enterprise environment to provision trusted execution environments at scale, right? If you were limited to that device and the sharing and loading of encrypted blobs was limited at the time, this was something that we felt was a shortcoming. And then I think lastly, blockchain uses a lot of non-NIST approved curves. And so we found so far that there's limited support for like P256K curves and things that are commonly implemented in blockchain environments. And it's hard to use these curves or to get these curves introduced into the libraries that are used in trusted execution environments. So yeah, so at the end of the day, the way we're looking at it is there's really two big opportunities for confidential compute, and we'd love to, again, engage with your community more often and really learn what the state of the art is, specifically for improved security at the enterprise or institutional level, and secondly, for scalability. So obviously, confidential compute helps us minimize the risk of using devices in the wild. We're not doing this in a closed, protected environment. We're talking about someone on the street with their cell phone using their Apple ID to try and interact with a blockchain. The confidential compute element really provides greater controls for MPC and helps reinforce a lot of our blind spots. And then lastly, it's becoming more and more accessible than ever, right? You can't run Windows 11 without the TPM support. Trusted execution environments are everywhere. There's been a lot of great progress in virtual trusted execution environments. I think this is really the opportunity where we have, as multi-party computation and blockchain guys, to learn more. And then secondly, scalability. One of probably the biggest challenge that we're having for deploying multi-party computation at scale in a permissionless way is increasing the availability of participants. And so if you are using a hosted service to go ahead and participate in an account, provisioning these at scale is incredibly difficult for us. Yes, Mike. I think you're still on mute.
Yep, sorry. I was wondering what you meant by virtual TEs. I'm aware of virtual TPMs, but not virtual TEs, and I have concerns.
You have concerns. I mean, I know that this was research that was coming up a few years ago, and I haven't checked in recently to see where it was, but it was, I think, largely backed by AMD. I'd have to pull it up. But it was an opportunity to, yes, Alec, please join in if other people know more about this.
No, I was gonna set up the next question after this answer, so please.
Okay.
Yeah, I mean, virtual TPMs makes lots of sense. Virtual TEs is kind of the opposite of sense if it's not hardware based,
Right.
because you lose your root of trust completely and you've lost the isolation that you have with hardware.
I don't think it had a lot of adoption. It might have been dropped altogether. But back when we were doing our research into trusted execution environments, I'd have to pull up the links. It's been a minute. But there was talk
Someone's
of.
found one.
Yeah, let's not
Okay.
rat hole on it. It's sort of a passing thought, I think. So
Yeah, sure. Okay, that's fine. Let's carry on. Thanks for the Stephen for providing a link.
Okay.
Yeah, so going to what you were talking about earlier, and some of the diagrams went by a little quickly, and maybe I didn't follow exactly right, but
Sure.
we're a hyperscaler, right? I'm with Microsoft Azure. So our business is providing confidential computing Ts using chips from our other friends on this call, Intel and AMD notably today, to actually produce trusted execution environments in the public cloud. You say that you use a lot of local compute, and just kind of want to get you to riff on the idea of where there's that boundary line where you're required to use local compute for the benefits that you get, and that the need for trusted execution environments in local compute so that you have some guarantee of actual randomness and other things, where that dividing line might melt away and allow you to use public infrastructure if we have confidential computing in public clouds.
Right. So probably this is likely the diagram that you're referring to. So in order to the original version of the protocol really focused on end users controlling all of their factors, right? Like the most basic integration would be myself as an individual has my mobile phone using a single sign-on. let's say a crypto browser-based wallet that can provide an additional signature, and then a backup using some form of hardware security, right? Like we were designing for blockchain. This was kind of our original intention. So your Ledger, your MetaMask, and your Google. Ta-da! I've got my 3 factors. I've got my account. I now have enabled account recovery, shared ownership, distributed risk, all these benefits of using multi-party computation in a decentralized architecture. What we found as we kind of kept pushing to try and find better use cases is that the level of convenience that the account had was substantially reduced because you have an individual that at minimum needs 2-factor authentication. And so we ended up developing a version of our SDK that was meant to operate as a cosigner, right? So it's consistently listening for opportunities to provide a partial signature that was user initiated. And so that really kind of unlocked a lot of doors for us when it came to scale. It also allowed organizations to start providing greater controls over the account, right? So you could deploy this in an enterprise environment, and rather than have it be quote unquote self-custody, it actually results in being a shared custody or permissioned access, because the organization would maintain 2 out of 3 of the key shares, and the end user would only have 1 key share to go ahead and initiate the use of the account. So that was all good and well, and now that we're really pushing more towards scale, there's limitations as to provisioning these cosigners, right? Like it's right now it's a hosted service. And the fact that every cosigner only has the cryptographic key material for the accounts that it participated in, right, means that you have to be reliably be able to provision these machines to go ahead and participate in these accounts. And so that's something that we've recently started to explore, right? Just how do we really distribute this load and kind of balance the requirements to perform MPC in this permissionless way at scale? It's been challenging so far, right? To be able to consistently get that key material in a hosted service that's able to quickly participate in this and then deprovision almost immediately. So it's something that we're pushing towards, and part of why we're here is to learn more and start getting in touch with the right experts to figure out what's the best way to really solve this problem for people that want to use our protocol.
Got it. When you're provisioning, you speak of having to provision massive numbers of machines at scale. You're comfortable doing that in hyperscalers. It's not a provisioning of machines where you control the physical hardware.
Right. And I guess just to further elaborate, we are like our protocol and our SDK, it's freely distributed. We don't do integrations at this point. What we're really looking to do is support the needs of people that are building on our protocol. And so for some of our more enterprise focused users, right, hyperscalers it's mandatory, right? And they're struggling to figure out how to use both KMS systems and confidential compute systems in order to deliver the scale that they need, right? Not talking tens of thousands like most blockchain projects, but looking at millions of requests on a regular basis. Cool. All right. Well, we front ran the Q&A a little bit. The last thing was scalability. So Alec, thank you. I think that ties in pretty close. Provisioning at scale. The other kind of complication with this is that with multi-party computation, in order to carry out one action, you need at least, at minimum, 2 signatures. And so you end up getting a lot of participants doing a lot of things for just one result, for one output, which means that, right, you're scaling depending on how many people are participating in these accounts. And then, just enabling enough of these cosigners and making sure that they're available in a way that's reliable and efficient without compromising on security is probably the biggest opportunity for us with confidential compute. So yeah, ta-da. Thanks, guys.
All right, well, that was great and very efficiently done, James. So I know we grabbed a couple questions along the way. I see there's at least one more set in chat from Alice. And Fritz has his virtual hand virtually raised.
Cool.
I'm
Why don't we
also
go with
standing
Fritz?
here like this. Should I go first? I can also go second if you're free to.
Alice,
go
would you
first.
like to read your question, or you want me to read it for you? I'll just read Alice's question in case she can't come off mute here. What's the cost implications in terms of compute resources? And secondly, are there trade-offs? Are we giving away throughput for security? I assume it's parallel computing since it's multi-party, right? How scalable is this solution?
Yeah. So cost implications in terms of compute resources. This is one of the major reasons that we focused primarily on local compute. All of the heavy lifting for us happens off chain. And so for us, that was substantially less expensive than trying to use a distributed virtual machine to do any of this. The trade-offs for us was definitely inconvenience and inefficiency, right? It takes longer to form a threshold signature than it does to just grab a private key and do an elliptical curve signature. The parallel computing bit, the multi-party computation, we actually go through several rounds of communication. I think, and my CTO would have to lean in on this one. I think we're doing 3 rounds of communication. And so it's not really parallel computing. One of the kind of advantages of our protocol is that it's asynchronous, right? It's designed for decentralized architectures. And so you can find faster multi-party computation in a permissioned system where you have greater controls over the different nodes, the different signers, and the channels of communication, right? You can reduce that latency that might enable parallel computing. But really it's more of it's an asynchronous process. I think that covers it. Alice, did that answer your question? I know your network is terrible.
Sounds like it
Cool.
did.
Okay,
Thank you.
excellent.
All right, Fritz, you're up.
So sorry if you answered this a little bit already, but maybe I want to bring that point home. So what now that you introduced TEEs to the mix, right, into the threat model, what pieces of MPC do we even still need, and can we not do many of them with TEEs nowadays? And I'm asking this not because I do like MPC, but whenever I thought about a mix of MPC and TEs, I very quickly had the feeling that they just have contrary threat model assumptions. And once you have one, you don't need the other anymore, which doesn't mean either of them is useless, but combining
Sure.
them, I so far very quickly had a slump or encountered a slump and thought, well, then I can just drop the MPC if I'm already like trusting the CPU to do the thing. So
Sure.
yeah, go ahead.
So I really think the advantage of multi-party computation is in I'm going to say we're trying. It's in an attempt to remove single points of failure, right? And that was the pushback that we got early on from the blockchain community, right? 2018, 2019 was this idea that, centralized attestation and root keys, master keys that then provisioned, right, using like a HD cryptography, heuristic, deterministic, creation of keys, that would put the entire system at risk if this single point of failure was compromised. Like an unusual fallout of that MSI master key being compromised a few years ago, there was one of the, I guess, victims in this case. There was a blockchain network called Secret Protocol that they were doing trusted execution environment nodes, and is basically TE plus blockchain. And their entire network was compromised for a matter of months because the master private key that was used to provision all of the trusted execution environments was part of that attack. It was leaked. Had they been using, again, multi-party computation in addition to trusted execution environments, it would have lowered the chances for that to happen, right? And not like distributed computation is by no means perfect. We've seen a lot of issues with like governance and just in general, like people not using good key hygiene for distributed systems. But by combining them for us, that's super, super helpful. The second bit that I didn't touch on in this presentation, and one of the major advantages of multi-party computation and the way that we're performing elliptical curve cryptography, is that once you've established a baseline and once you've established this public address, you can in perpetuity use a process called key resharing. to go ahead and recombine key material and then redistribute it, effectively choosing additional points along the curve to go ahead and issue new key shares, right? New individual parts of key shares to the participants without changing the static permanent public address, right? So if you have a collection of devices, if we're using this at scale, right, using a hyperscaler, you can maintain the same public address for all of these services, but on a regular and frequent basis, rotate the security credentials without compromising its ability to form a valid signature against the public address. So this idea of a dynamic private key material that is also distributed at scale is really one of the stronger advantages of multi-party computation. And just being able to do that securely with trusted execution environments for us means that we can do this for longer periods of time safely at a greater scale. I hope that at least answered part of your question.
Yeah, it does. And Dennis already saying we might want to move on.
Okay.
Do you have a second to elaborate on the root key loss that you mentioned? So is that something you just remember, or was there something concrete? Because
it was something concrete.
Mm-hmm.
I'll look it up after the.
Kind of
I'll look it up after
on something that's okay. Go ahead.
I'll look up the incident as soon as I'm off, and I'll go ahead and post it in the chat.
Yeah, great. If you remember, no worries. I mean, also like not trying to push you on something that you just remember.
No.
Right?
It was,
but just interesting to hear about what has been seen from your end.
Yep. Let me go ahead and find it.
Awesome. Yeah. Thanks for the call. Thank you.
Okay.
All right. Thanks so much for the talk, James.
All right. Thank you, everyone.
All right, so let's do a little bit of palate cleanser between tech talks. We're going to jump back into our 2025 planning, and I promise for Professor Cheng's benefit to keep this as brief as possible. Just need to get my window back here. You should be seeing the slides again. All right. So we actually made a lot of good progress last session, having everybody figure out how they're going to be volunteering their time of at least amongst the TAC voting members here, so that we all have some responsibilities to look forward to in the coming year. I want to grab my attendees window again so I can double check if we've picked up Ming Shen. It does not look like we have, or Catherine. So they were pretty clear though on what they were going to be doing last time. So Catherine continues to work on the Linux kernel SIG, and Ming Shen had added some new ideas in the project categories. We're going to go walk through these in a second. We don't have Nathaniel on, but he and I spoke offline a little bit. And I don't know if he's gone in and updated the document. And again, we've got Ming Shen double listed here, so we might want to clean that up. And then last time, Paul, we had a good bit of dialogue, and I think I saw that you have updated the objectives doc.
Yeah, hi Dan. Yeah, so I've put in some updates in suggest mode.
Okay.
And yeah, so the summary I think of what we talked about last time is I talked about some stuff that was particularly around the Verizon project.
Mm-hmm.
And I think we decided that project-specific things did not belong in the Oscars, but instead belonged in like project-specific growth plans, so that would go elsewhere. The thing that I did suggest in, which we also talked about last time, is around this topic of providing educational materials and providing end-to-end proof of concepts and demos and things like that, which is something that I am involved with. So I put in I suggested an objective, I put it into the ecosystem category.
Okay. Yeah, we can go take a look at that. Let me just do the simplified bucketing here so I've got people sorted. That fair like that?
Yes.
Okay. And then I have to yet catch up with Henry and Kevin. Howard and I had a good one-on-one, so this time slot is always quite terrible for anybody in China, though certainly appreciate people who do regularly join from Korea and elsewhere. So I think he's added some updates in there too. I just don't remember off the top of my head where those ended up. So let's just do a little bit of cleanup and then we'll get on our way here. Okay, so the first thing on here, see if I can get a little bit more screen real estate, is in this ecosystem buckets. There's Alec, did Mark add these, or was this you?
It wasn't me.
Okay, so I believe this I'm not sure if it's called Whimsy group, but they have some workload definition practice going on. Does that sound familiar, Alec?
Yes, that's something that's been discussed in the GRC SIG.
Yeah. Okay. So I'm just going to take this additional thing that Mark has here, and I'm just going to say that it's captured in the elements that he's put up.
Actually, now that I'm thinking a little bit more clearly, I did add those based on discussions. That's not something that Mark has specifically signed off on, but I think it makes sense. So those are things that I added that I think make sense, but probably need to double check with them.
Okay, so I'm just going to note that there, resolve this, and then he will maybe see this, but I'm just going to clean that up.
I think we've got a GRC meeting. Let me check my calendar.
I feel like he may have sent a end of 2024 note.
We've got one scheduled for next week. I'll put it on the agenda to discuss this.
Okay, so
Do you mind sharing a link to this version of the doc to the chat so I can just copy and paste it and add it to the agenda?
Yeah.
Thank you. Got it.
Okay, and then so I guess this is something that Nathaniel was going to follow up with, and Usama has worked to add in some of the attestation SIG. So the attestation SIG's been working on a couple of these TLS related protocols and trying to get those through standardization. Not 100% sure if that fits in this bucket or not, but that's good for now. And I don't think we have anybody from that crew to comment on that.
So I have some awareness of that work. It's interesting that it's been sort of tagged on to the objective because it feels almost like a that specific bit of TLS work is more specific than the objective as worded, right? Because the objective is really all around attestation, aligning on protocols and formats. Or TLS is really only one use case for attestation, so that feels like a. I mean, it has been put in brackets with example, so yes, I get it. Although it just, to me, just feels a little bit lumpy having it put on to the end of the objective there. The only reason I say this is because I have some interest in this objective as well, right? So Nathaniel has picked it up as the owner, but this is something else I would like to work on with Nathaniel and others and the rest of the community.
Okay, yeah, so feel free to grab that and throw that into a separate KR on Usama's behalf, or edit it, or just comment on it and see if he wants to redraft it.
Yeah, I know Osama, so I will I'll connect with him and see what he thinks.
Okay. What I think the original goal of that objective is that we're all pretty familiar with attestation, and it's not a confusing concept for most of us, but you don't have to go too many degrees removed from this community before it looks like a soup of acronyms. And so the more that we can produce that just clarifies how it's used, and make it more adoptable and approachable by other technical communities, the more I think we'll see it used effectively.
Yeah, yes, I agree, and actually so the objective that I'm suggesting, which is more about educating,
Yeah,
might actually be
100%.
more relevant. It is actually creating these approachable, bite-size, comprehensible, end-to-end stacks that can be put together just for themselves, that help actually understand the flows rather than be integrated into big heavyweight production grade projects. That's the one that I've suggested there in the pink.
Yeah, I think that's perfect. And so if you could even, just to simplify things, throw those KRs up under this one or reword this one. Unless Nathaniel, I don't think Nathaniel had anything specific. I think this was pre-existing text from last year for the objective. So everything you just said
Yes,
about
okay.
education was in the spirit of what this thing was written to do.
Well, I think, yeah, I mean, it's interesting. I should probably have a chat with Nathaniel about it, but I viewed this objective as being the one that your cursor is hovering over now. I think that's less about, well, my interpretation at least is that is less about educating communities, and it is more about actually aligning protocols and formats so that we don't end up with a fragmented ecosystem for attestation, right? It's
knowing
real
Nathaniel,
commonality.
knowing Nathaniel, I think it's likely to be on the technical side that he's most interested.
I think you're probably right, Paul. The more you say there, yeah, I think some of this was what we talk about in the attestation SIG, that if you've got, I don't know, conceptual message wrappers and somebody else is doing something else to try to aggregate attestations, then yeah, we want to kind of all get on the same page. So I think you're right. This one is a little bit more about alignment within our community, and then education outside of our community is fair to have a separate objective. Okay. But feel free to drop all that stuff into comments or text in there. All right, Yash, do you want to talk us through what you've added here?
Yeah, so this one actually comes from Emily Fox, who is Red Hat's representative on the governing board. This is a natural follow-up, or let's say a build-up to the objective we had last year, which was to promote the best practices patch. So OpenSSF also has a security baseline definition for open source projects, and her recommendation was that CCC projects adopt and define their security baselines. So there are different categories, and then there are different maturity levels based on the size of the project. The best practices badge is more broad, that shows the overall quality of the project, or let's say adoption in terms of overall health. And the security baseline is more security focused. So given that we are the confidential computing consortium, I think this is something that we should be looking into, and we should be promoting our projects to adopt it. Another recommendation that she had was that if the CCC projects could help other broader, open source projects adopt security principles by collaborating with us, or using our technology, that would be a plus as well. So the objective is more to look into it, and not to, it might not be right for us, or we can choose not to adopt it, but we should probably be looking into this. And I agree with her.
Yeah. Yeah. Okay. So for other people's benefits too, there's this open source security foundation, and they have a badge that has a bunch of best practices, and then there's like 3 levels of badge. There's also a scorecards project, excuse me, that has will analyze your repos and give you a score. And now there's also this baseline, which is less automated. Excuse me.
Okay, then.
Yeah. Actually, I'm gonna grab some water. So why don't you fill time for me, Yash?
So
and talk about
I
this
had a question for Sal actually. Sal, is this something that you've been thinking about looking at? Are you aware of it?
Yeah, I mean, we're making the decisions now.
Cool. So it's something that's already in train, at least partly. Cool. Well, I thought. Good.
Yeah, so I actually looked at the current CCC projects, and I think apart from Oculum, and Manatee, which was only recently accepted as a CCC project, all other projects are already underway with the best practices badge program. Like, it is displayed on their GitHub page, and most of them are above 90%, I believe. I think Vorti's at 43, but others are 86, 97, Enarcs and others are even passing already. So this would be more focused on just making sure, well, not just making sure, but on making sure that the projects themselves are secure. Because there have been efforts in the open source community to sort of, let's say, affect maintainers or use tile maintainers to get security flaws in, or exploit flaws. So I think this would be a good way to make sure that CCC projects are more resilient to such attacks.
Okay, cool.
Are you better now?
I don't think so. We'll see. Got a tickle that won't leave the back of my throat here.
If you need to drop
Yeah,
and
so it
get
sounds like
something hot or whatever to drink, feel free, and we can definitely keep going.
We'll continue.
yeah, I I think I'll be good for a minute. So it sounds like one of the first results would be developing a proposal. So maybe the proposal is we want to trial this with one volunteer project, or we want to set this as an entrance criteria for a certain stage of our project progressions. Yep.
Yeah, and I also agree with Sal's last comment, which is that if maintainers would like assistance with adopting this could be a very good mentorship project. Sorry, Sal has their hand up. Yeah. Sal, go ahead.
Yeah, I'm gonna just 2 points on this. I'd like to work on standardizing this as a known requirement when projects onboard so that they get it done right away. And second, I will note that over the last year, we did have some OpenSSF security implementations. There were some language barriers on some of the projects to getting those implemented. So I think as we get that onboarding, getting feedback from the projects and knowing how we can provide CCC specific instructions is going to be really helpful.
Okay. So Yash, I'll just recommend that you word one of the first key results as coming up with the proposal.
You can do that.
All right, I am gonna get us on to the next topic here.
Just a point.
Oh, I'm sorry. Did I cut you off?
No. I've been actually tagged to multiple things, but I see that Howard has put his name for the objective under community to seek out and welcome new contributors. So, you can take my name off of that. So then I'm focused on two and I'm not doing, I'm not stressed across multiple things. I can still work with Howard, but I would want to work on the health measurement, the community aspect, and the security baseline objectives.
Okay, great. Rian, could you coordinate with Howard and make sure that that's his intent is to pick that up, and then get him noted on here with whatever the Google magic is to identify him correctly in the document?
I can do that.
Thank you very much. Okay, so get back to the list of participants. So now I would like to re-welcome Professor Cheng to the call. He's volunteered to give us a talk. He is the lab director for the UCLA's voice is going to stick with me here. For the UCLA's Trustworthy AI Lab, is also the graduate vice chair and professor of statistics and data science. So welcome, Professor Cheng.
Yeah, thank you for a nice introduction. I apologize for being late. I guess my my background is very different from everybody else, but I would like to bring a use case for confidential computing here. I'm very eager to join this community. So my shared screen. Okay, I think here we go. Well, can you see my screen?
Yes, we can.
Okay, cool. So
though we do see the presenter view.
Oh yeah, you can see it, right? So my screen.
Yeah, but I think you want to do this. Go to the display settings and swap.
Oh yes. Let me swap that. Give me a second. A second. Let me try. This way, probably you can see. Now you can see my screen, right? I assume.
Perfect.
Okay, cool. Yeah. Thanks everyone. Sorry if I'm late. This talk won't take too much time, so I have a very different background, but I hope the use case I bring up is of interest to this confidential computing community. As Dan just introduced, I have worked as a professor for more than 15 years. Currently, I'm in UCLA directing this Trustworthy AI Lab. Okay. So first of all, I want to talk about the vision of the whole lab, which I worked for more than 1 decade, and how that can align with confidential computing. First of all, our lab believe I work on AI and machine learning, as you will see. I think the stricter regulation will be the major driver for the second, I call it AI 2.0. It's moving from the AI 1.0 is mostly on the performance oriented. I think in the future, I think it will become trustworthiness oriented. There are so many evidence, so many ongoing research to already show this trend. The safety AI is a hot topic right now. In the past, I have a long-term collaboration with the industry actually. Let me start from introducing my lab. My lab has about 20 students, including postdoc, PhD students, master, and our publications are mostly in AI and machine learning. Sorry, I don't know much about hardware, but I know hardware is super important. It's going to be more and more important from my own experiences. So the publications are mostly in Neuro-East, which is right now in Canada, and the ICML, ICRR, KDD, and I also publish theoretical research in statistics journals. And I have one academic collaborator. Maybe some of you know him, Xiaofeng Wang from Indiana University. He got recently a $9 million grant. to set up a NSF Center for Distributed Confidential Computing. We have worked together. And I also work with many other industries who care about the privacy. But as you can tell on this slide, I care mostly about the privacy and security in data. Okay, I will be more concrete there. But from my experiences collaborating with like JP Morgan and Meta and also in the Cisco and Amazon, they all care about what I'm working on, but their focus is more on the data privacy and the data security. Okay, so as my collaboration and my research going deeper and deeper into the trustworthy AI, I noticed that I should collaborate with a confidential community, a confidential computing community. Okay, what I work on, okay, in recent years, the first one is on data privacy. Data privacy is a very broad topic, right? It can mean a lot of things. Particularly what we work on the synthetic data. Okay, that's a relatively new topics, especially as large language model becomes popular. In the past, like 5 years, no one used a large language model. I mean, and anything similar to that to generate synthetic data. They use a very traditional machine learning approach or even some parametric statistical models. But here, people use large language model to produce privacy preserving synthetic data. Okay, and that's one research areas I work on. Another one is on the large language model itself. So for example, how can we co-train a large language model in a TEE? Okay, this is unclear to me. I would like to learn from you guys. I mean, this is very critical because once a publicly available large language model like Llama available to you, and then multiple enterprises would like to fine-tune it. However, while you are doing the fine-tuning, you may have to collaborate with another company. For example, different pharmaceutical company are doing clinical trial for the same disease, right? They do have some data to share to co-fine-tune a large language model, but they want to protect their data not being seen by another pharmaceutical company. Okay, this co-training or co-finding of large language model is very important when the data become very sensitive. Okay, and this is certainly we need to use some advancement in the hardware, not only some of the algorithm things. Okay, what's the strong use case driving the my research? Okay, in this data privacy and data security, that is a digital marketing. I'm not sure how many of you know about this this industry, but this is a area that a lot of data are highly sensitive, and there are a lot of rules regulate how you communicate using the data. Okay, so let me look at this plot in the right. So notice we have 3 rows. Okay, I'm kind of simplify this ecosystem in digital marketing, but you have a marketer, you also have a machine learning engineer, and you will have data scientists. They communicate the data to each other on a daily basis. And data they communicate can be highly sensitive. Say your feedback on the advertisement, your credit card number, where you are, okay? And what browser you use to view this advertisement, you buy this product or not, okay? All this information can be, we call it a PII, personally identifiable information. So let's look at this ecosystem. So one marketer like launch a marketing campaign that actually send this request to the engineer to launch it. And after machine learning engineer launch it, they will request the data scientist to analyze the ad data. So how many people view it? Okay, what feedback is? And the advertisement and the ad data scientist, after they do the analysis, they will send back their report to the marketer, okay? And then they will keep refining how they do the campaign. Along this circle, then there are a lot of sensitive being transferred, okay? So and then there are a lot of regulations here I wanna talk about. So many of you already probably realize that's about the cookie, okay, which I will mention. So first of all, when you click a website, you visit some websites, they require you to choose. You have the option to accept or reject the cookie upon every visit. This is by regulation. Okay, so either GDPR or CCP, you have to do that. You either reject or accept. And because the data they collect are very sensitive, so if you choose to reject, basically they lost the track of your data. This gives there a big difficulty in noticing the effectiveness of the advertisement in that website. And also they have the Digital Market Act. So they actually add a further pressure on this platform. Let's say the Amazon, for example, then they have to enforce a even stricter data sharing practice on the user data. I don't want to go very details, but I just want to you be aware that this trustworthiness becomes super important because AI is no longer a very modern technology. So government has to impose much stronger regulation. So if you are aware, like last October, White House has a executive order saying you have to do, for example, the watermark on all the generative products, or for example, the text, the conversation, or the image you generated by AI. So you have to put a watermark. Okay, there are a lot of things ongoing there. So we have to protect our privacy. And the one consequence on this digital marketing is that people in this domain shifting from the third-party data to the first-party data. Okay, this so-called cookie deprecation. So what's cookie deprecation? That means in a few years, actually, Google plans to do that this year to deprecate all the cookies in their browser. Okay, in that way, then this actually fundamentally changed this the business model in the digital marketing. Okay, so the company will now rely on the first-party data on their own website to collect and manage, all these customer insights. Okay, so I tried to give you a use case, but I think probably you have some question which I can get back to answer this. But this is actually the driving force on my research. Okay, what's the connection? What's the connection with confidential computing? Let's look at this. This is actually a data collaboration platform. So when we have multiple data owners, they want to exchange their data, and their data are very sensitive. So you can imagine this. First, this data owner is the advertiser. The second is the publisher of their advertisement. And the third person here is the second publisher, right? So you can publish or advertise in different publishers, right? So, and within this data collaboration platform, the current SOTA, the state of art, is that they use the differential privacy to protect all the functions. And they have at least 3 functions in this data collaboration platform. You probably heard about the name called data clean room. Okay, that becomes a industry standard in this domain of digital marketing. They can either they join multiple tables from different data owners in a secret way. Okay, I mean, here the point is that we are going to join the 2 tables. In this process, these 2 data owners will not know each other's data. They only know their own data, and also even the owner of the data collaboration platform, the one to provide this service, will not be able to see it in the ideal case. Okay. And as you mentioned, this is here not only just the storage of the data and transfer the data, also involve the computation of the data. That's where confidential computing play a role. So the second function usually in such a collaboration platform is about the co-training of the models. So we care about the same model, classification or regression, random forest, whatever machine learning model, or even reinforcement learning models. The training data are from different parties. Okay, we want to train that. And also, when it's finished, I want to transport back the gradient or the model information to each data owner. And we want to make sure no one can infer the sensitive data of another party simply based on the model information they just transfer back from this platform. The third function is recently become very hot topic. It's about large language model. They use RAG, all this fancy, retrieval augmented generation, all the technique. Well, they are co-training a large model in this secure, what they claim to be secure, but probably by your standard, it's not so secure. Okay, in that platform, in this black box, to do all type of computation. Okay, usually they call this function has a name called intelligence, and intelligence provider means this can be a third-party service provider to, okay, I put a synthesizer to generate synthetic data. I'm the third-party vendor that I can upload my algorithm into this platform so that all the data owners can choose to use. Okay, they are called intelligence provider. Okay, this is a very abstract way to describe what's going on here. And then how to connect with confidential computing. Okay, this is currently, I think, lacking. I think I put some of my thoughts here. First of all, let me summarize what are the key components to be protected in this data collaboration platform. As I said, this is a strong use case, in my opinion, on the confidential computing. The first one is about data aggregation and analytics. Okay, they just compute, for example, the sample mean, right? The second is about machine learning or reinforcement learning model building. The third one is synthetic data generation. The last one is the co-training of large language models. All this has been used in this digital marketing and many other like domain as well. In general, we are interested in developing a TEE-based platform for secure or private data collaboration by addressing the two challenges. You guys are experts here. So I just throw some random thoughts. First, the challenge is to establish a trust chain from firmware to application layer and the different policies. GDPR, HIPAA is for the healthcare data. The second challenge is to ensure the high performance and the privacy across different TEE in CPU or GPU. You know, when you do this confidential computing, you expect some performance degradation. Okay, sometimes it's okay. Sometimes in some domain, you have to still maintain both the high privacy and also high performance. Okay, so here are the two challenges I can expect. Here is something I think a TE can provide. What I can is what you know as the data in use protection. So let me explain a little bit. There are some terminology here. So the usual data pipeline. Okay, that is every industry have their own data pipeline, but they do have a data pipeline. They might include the mapping service, matching service, and aggregation service. That's the three major services digital marketing need. And what I meant by matching service, that is a process to create a common identity space between advertiser and the publisher data set. They need to know they are the same person, right? The person A watch this advertisement and then buy the product. They should be the same person. Okay, this mapping service. For the matching service is responsible for finding the intersection between network engagement and advertiser app conversion. This take into account the attribution parameters such as the lookback window. And the last one is called the aggregation service that is responsible for aggregating the matching results for a specific day. The advertiser and the network can set different dimensions of the aggregated data. This in mapping service, actually the digital marketing even have a protocol for how you do this to protect the user data privacy. So the mapping service use the private set intersection, the PSI, to create the so-called AD-MAP. That's their protocol way to call the ID on the blended data sets from publisher and advertiser. And we hope that the TEE can provide data in use protection on both the data and the intelligence. The data here include the mapped exposure from publisher, attributed conversion table, joined from the exposure table, and the report from the advertiser. Okay, sorry, I have to put quite a bit terminology, but I want to give you the impression that for many industries, particularly in digital marketing, we need to protect the data in protection using TE, which I believe has not happened yet. And I think that basically conclude my talk. So I expect question and yeah, I look forward to joining you guys. Yeah.
That was a great talk, Professor. Thank you.
Yeah, very.
I'm sure we. Go ahead, Mike.
Yes, I was going to say very interesting. A number of use cases have gone into in more depth and from slightly different angles to ways that I've certainly looked at them before. And I think this is very, very useful and very interesting. And I think it would be great to have you guys joining us. So from my point of view, it sounds like a very good thing. Yeah, I'm aware of some of the marketing ad tech stuff, but as you see, you've looked at it from a rather different angle. So yeah, I mean, from my point of view, I think it makes a lot of sense. Does anyone have any specific questions? So I just wanted to kind of give my vote of I like it.
I have all sorts of questions queued up, so
I bet you do.
we'll let people get some of their thoughts together. First, I want to mention that we do have a project that might interest you. One of our new projects called Manatee, so spelled, I guess, like manatee. And that is a data clean room oriented project, recently contributed by TikTok. And Yash has dropped the link for that in the chat. So that might be interesting for you and your students to take a look at.
Okay, yeah, cool, yeah.
I am curious first if the idea of a data clean room, you feel like that is a strongly defined term, or if it's something that's kind of, I don't know, squishy.
It's a good question. This concept originated about 4 or 5 years ago. Okay, so right now, almost I would say, at least I know that Amazon, they have the data clean room service in AWS. You just search the term that comes up, and Google also has that. Google probably the first one to set up data clean room. The third one is the Meta also have the data clean room, but they only available for the internal use. You will not see it outside. We collaborate with Meta, so we know this. And the yeah, I think all these big guys have data clean room. There are, I would say, maybe 10 different startups also doing data clean room. So it's gonna be growing to the second version. I would say, what do I call? I mean, the first version is pretty well established. The second version is the AI-driven data clean room, which is being developed. For example, in the current version of data clean room, nothing has been computationally intensive in the sense like large language model. None of the data clean room include that. That's something we are doing. So when you do the large language model, so I'm not sure how confidential computing can support that. I don't know. So there are a lot of unknowns. I talk, as you tell, I collaborated with Xiaofeng Wang. So we do identify a lot of research and also business needs for this confidential computing. Yeah.
Yeah, I definitely see a need for it. I think something that would be like an interesting output from academia would be like a strong definition of like a data clean room. You could go test somebody's offering, not physically test it, but you could test if somebody claims that they're offering a data clean room, it must satisfy, I don't know, let's say 3 tenets. It must protect A, it must protect B, and must protect C. I think that would be sort of a useful way to clarify people's expectations around that term.
Absolutely. Absolutely. There is one department in government, I forgot which one, I can bring this up in the next meeting. They suspicious that they have a research article saying, indeed, how much secure the data clean room all this, you know, startup or big company develop. They do question that, just published last month, because none of them has used the confidential computing yet. I mean, this Manatee, I'm not sure, I haven't read it. So that's one point they attack, saying, okay, you claim data clean room is secure, but why now use confidential computing? Yeah.
See Sal's hand raised.
Yeah, I really enjoyed this presentation because it used language that's much closer to what privacy lawyers are using when they're thinking about this subject. So I think it's really nice and interesting, particularly they're working in the advertisement space. So I think it would be really interesting to follow up on this and learn how we can bridge the technical way that we speak about this subject with the way that you presented it, because they're both correct. And I thought this was really good.
Yeah, thank you. So I want to bring up a conversation with JP Morgan, the lawyers there. So about 2 years ago, we used a differential privacy, some like a software approach to protect privacy. and to say, okay, I add some noise into the data, so your privacy got protected. They don't buy it. They say, I would like to see some hardware, protection, not just show me a mathematical formula saying it's protected. So yes, indeed. So we talked quite a bit with lawyers in different industry. They do think very differently what kind of privacy should be protected and how be protected.
That's interesting. We've got a regular contributor from JP Morgan who joins, who's not here today. I would have loved to get his reaction on that. So I see a question coming in from chat. Alice asks, she says, Professor, great work. Love I love every bit of it. I have a question. Is the solution integrating ML/RL and LLM in one? Seems heavyweight, isn't it? Or maybe I missed a crucial part with your explanation.
Okay, this is a very good question. This is relevant to what we plan to do. Okay, I can tell you this is something we are developing. Okay, so of course we haven't incorporated confidential computing. This will be part of it. And for the tabular modeling, or say the table training, this has been done. For the model training, I would say half done. Okay, we already implement a lot of model training, random forest, or what kind of machine learning we know people use in industry. But for large language model, this is really heavyweight. We have a prototype, but so far the performance is not so good in terms of speed, and the accuracy is probably not so well. But I would say table training, this basic statistical analysis is okay. People have done, but the machine learning have done only by our lab so far, as I know. And we have some prototype for large language model, but it can be improved a lot here. Yeah.
Okay, great. On, I think it might be your following slide, you had private set intersection listed.
Yeah.
So
PSI,
sometimes,
yeah.
Yeah, so sometimes there's cryptographic protocols that will do things, and then kind of like questions that Fritz asked for our last speaker. If you can do something inside a TEE, you typically don't use one of those. What is it that you're proposing here for private set intersection?
Okay, this is something we haven't done yet. The reason I put PSI here is because the digital marketing, this industry, they have something like a consortium, like us here. They call the IAB. Okay, they have released a protocol for data clean room. Okay, in the past, there are many different versions of data clean room. They are trying to have a consistent definition and a protocol for data clean room. And they particularly propose the PSI should be the one to create the so-called blended IDs. Okay, but how to do that? We are still working on it, and we know that we have to follow their protocol. Okay, but that's all I know at this point. Yeah, I definitely need to clarify with you guys. Yeah.
Okay, that's interesting. I wasn't aware of the IAB weighing in on this.
Yeah, they just released last month for the protocol on this data clean room. That's one particular requirement they put in PSI.
Yeah, that's definitely something for us to follow up with. So we have a number of contributors in our community that also work in IETF and attend the IAB meetings. So it'd be good to help generate some collaboration with them as well.
Yeah, great.
Okay, questions for anybody else for Professor Cheng? Okay, well,
so I have a comment rather than a question, which is that there'll be a request from the GB. Well, the GB needs to decide whether to accept the UCLA group as an associate member, and we might want to express an opinion based on this. My view would be positive, but just so that we can feed something back to them, even if it's just from your point of view, our chair and co-chair, how you feel the the view of the group was generally.
Oh yeah, I don't think we typically weigh in on associate membership proposals, but clearly a lab at UCLA and something so close to what we're working on here is very welcome.
Can I ask another question?
Yeah.
Sorry, go ahead if you want to finish this.
Yeah, it's just to say that the possible associate members are typically asked to talk to the TAC so that the TAC can form an opinion. That whether that's a yes or a no, at least we can feedback. That's all. Cool. Thank you. That's
sure.
So I just wanted to have one last more meta question. So you may have seen in the year goals that we discussed earlier today that we also have some discussions on how we do academic outreach and what forms that might have and how we do it. And yeah, well, with whom is I think less of a question once we know what we want to do. But what is still unclear is a little bit of what would even be the benefits and what could we even as a consortium contribute to labs here. So can you maybe say that from your perspective a little bit? So I know a little bit of my own academic history, of course, but everyone has different contexts. So what would you see as a benefit from the consortium in general, of course, but also what, let's say, medium to low effort thing could the consortium do other than maybe giving money that would have a great benefit to research that you see?
Oh yeah, I mean, one clear collaboration is just in terms of research, you know a lot of things. I don't know the hardware, but I see a lot of motivation and use case and how AI and machine learning can work with confidential computing. I think that's a very clear benefit. And the second thing I would say I can benefit is to learn the most recent advancement in this domain, which without joining this consortium, I can only read from maybe the papers, which usually a few years later than the most recent source. All you guys are thought leaders in different, hardware or confidential computing, domains. And the second thing, I want to stay alert of all progresses. And the third thing is that I want to know about the recent news in industry, in confidential computing. Maybe somebody else already developed a data collaboration platform in my mind, but I don't know, right? So you guys know everything going on. And as you can tell, I'm already collaborated with all this industry in many different forms, not just give money. I send also my students be there to be intern. And I also collaborate with Xiaofeng and, NSF, National Science Foundation is very, very interested in the confidential computing. I can tell you, Xiaofeng and I just submitted another proposal on confidential computing. Some of it is I put in the talk, and NSF would like to invest that as well. So I think that will be the future. So I would like to be part of it. Yeah.
So I had a brief comment, which is just to note that I don't think we have a mechanism by which we can give money to academics, although there might be occasions on which we might think about funding sort of MA or postdoc topics, I suppose. I think that there's lots of sort of cross-learning opportunities. I mean, for instance, as Sal was saying, the fact that Professor Cheng is, looking with a more markety hat on, or a different approach or a different vector, if you will, gives us more reach, and hopefully, as the professor noted, being able to speak to the people across the industry and come up with ideas and talk about those ideas, and we can discuss them here. I think will be beneficial to everybody.
Yeah, I'm more like a
that's
channel.
why I
Yeah.
explicitly go ahead, sorry.
Oh, sorry, I'm more like a channel between here and academia. Here is yeah. Sorry,
Yeah,
please
that's
go
also why I
ahead.
explicitly asked for other than money, right? Because money, I don't
No,
see
no
them as
worry
like a
about the money.
low effort
So
thing exactly.
I'm not here for the money. No worry about it.
Yeah, no,
Yeah.
exactly. But that's what I'm trying to say is that I think having these technical discussions is sometimes also easier to sell to our respective companies to motivate some outreach. And so I'm very interested to think about how we can establish a forum to enable that while still being under the open spirit of the Linux Foundation, right? I think that is then where it may clash on the academic side, where if this happens under the Linux Foundation umbrella, then of course it has to be something open where everyone can benefit from this, which sometimes clashes with I don't know, paper processes where for half a year or 1 year you don't want to talk about your ideas because otherwise someone may scoop you for it. So I think there is this mismatch, but we can discuss it. And we can think about that. But of course, yeah, I mean, there's also already respective I think research programs going on. You have some on your listed, right? So
yeah, and the
it doesn't
LF
have to be under
have processes by which we can collaborate. This is something that the LF does quite a lot, and other places as well. So I don't think we need to be too worried about it. But yeah, we need to be careful. You're quite right.
That's good to know. Okay, thanks.
Yeah, I mean, it's usually very easy to collaborate. We're open, transparent. I mean, ultimately, we're an open source organization, so I think that's another point of opportunity for your students is, for example, that project that we mentioned, Manatee. So if some form of implementation they want to take on, if that project represents something that they want to contribute on, then it's an opportunity to work alongside industry professionals. So they'll get that sort of industry flavor for how we develop software and open source best practices. And kind of get maybe some learning through that venue, and the other direction as well. So there might be people in the Manatee community that see benefit from a different approach that you've initiated in your lab, and if you've got open source code, then they can contribute there as well.
That's great. Yeah. So so without coming to this meeting, I don't know this Manatee. That's already benefit I got.
Yeah.
We're definitely very happy to join this open source. Yeah.
Great.
Yeah,
okay,
I can also, sorry, the last thing, in the past experiences with industry collaboration, I'm happy to host whatever workshop, physically in UCLA campus. That's what I did with JP Morgan and Amazon before, just like that's something I mean, maybe if that's beneficial to the consortium, I'm happy to host a workshop,
Oh, that's very welcome. We're talking about, there's a open source conference called FOSDEM that takes place in, I think, the Netherlands. And so we're looking at trying to get, or we have space, but we're going to look at some of us being able to meet up there early in the new year. But it's been very rare for us to have like a physically present meeting where everybody's physically in the same spot. So I'm sorry. Brussels, Belgium, not
Indeed, yeah, you'll get people very upset from Belgium if you suggest it's in the Netherlands.
But at any rate, yes, thank you. I think we would love to be able to take you up on that for a workshop.
Yeah, thank you. Yeah, that's all. Yeah.
Thank you so much, Professor Cheng. Good to see you.
Thank you. Okay, let me stop sharing.
Okay, so we're going to wind down to the end of this meeting. And I think the last thing is just kind of talking about the next time that we will be on the phone together. For this meeting is January 23rd, I want to say. Yeah, January 23rd. So when we come back together, one thought is we might want to scrub up the list of project liaisons, and then we already have a couple tech talks scheduled for the beginning of the year. And a little bird tells me we might have a new project proposal to be discussed as well. The remainder of these slots, we want to start filling in with the annual check-ins with the projects, and then of course any other additional project proposals that come in. So I just wanted to flash up the currently pretty clean calendar for 2025. Any other closing thoughts as we wrap up here?
Happy holidays. Celebrate whatever you celebrate. Christmas, Hanukkah, New Year, anything else. Thank you for such good work over the year, everyone. It's really good. Thank you.
Yeah,
Likewise.
goodbye, everyone. Yeah, goodbye.
Merry Christmas, Feliz Navidad, Joyeux
All
Noël.
of those things. Yeah, cool.
Yeah. Happy Hanukkah.